Welcome to this episode of AI Frontiers, titled The Eyes of AI, Vision Breakthroughs. This presentation synthesizes 64 papers from October 28, 2025, exploring cutting-edge advances in computer vision research and highlighting generative, robust, and multimodal innovations. This presentation unpacks the latest frontiers in computer vision through a thrilling synthesis of 64 recent papers, evoking a foggy highway adventure where AI sees through the mist. The discussion covers field basics, key themes, findings, methods, standout papers, and future paths. Engaging stories blend technology with real-world impact, from self-driving cars to medical diagnostics. Aimed at curious minds, the content demystifies how machines perceive and reason visually, sparking new ideas. The episode ends with details on AI tools used and a call to subscribe for more insights. Computer vision and pattern recognition enables machines to interpret visual data, such as detecting objects in images or videos. Its roots trace back to the 1960s with pattern matching experiments, and it has exploded in the deep learning era thanks to convolutional neural networks and datasets like ImageNet. This field covers self-driving cars, medical imaging, security, and entertainment by processing pixels into meaningful insights. It is evolving toward multimodal systems that integrate vision with language, sound, and physics for intelligent interactions. These 2025 papers highlight innovations in generation, robustness, and applications, transforming everyday technology. A key theme in these papers is advancing generative models for synthesis to create realistic images and videos. Focus is placed on producing collision-free videos and stitched views. Song and colleagues enable stable video generation along arbitrary paths, avoiding crashes in autoregressive processes. Deng and colleagues use uniform discrete diffusion for scalable, high-quality video outputs with metric paths. Wei and colleagues optimize efficiency via mixture of experts routing in diffusion models. This theme builds towards seamless virtual reality and animation, connecting to real-world applications like robotics. Another dominant theme focuses on robustness and safety in vision systems, defending against vulnerabilities and biases in visual models. Zhou and colleagues reveal universal adversarial attacks that make objects vanish in segmentation tasks. Kanagalingam and colleagues enhance classifiers for diabetic retinopathy with robust perturbations like adblur. Zhu and colleagues improve clip via contrastive learning for better generalization and attack resistance. This theme ties into ethical AI, ensuring safety in critical areas like autonomous driving and healthcare. A third theme integrates multimodal approaches, blending vision with language and more for reasoning, especially in medical and cognitive tasks. Aquaviva and colleagues show that video pretraining boosts adaptability, outperforming language models in efficiency. Myronenko and colleagues develop reasoning models for step-by-step chest X-ray analysis with explanations. Hu and colleagues explore conflict adaptation in vision language models. Mimicking human cognitive control. Attention mechanisms are introduced, allowing models to focus on key image parts, like a spotlight for better understanding. This multimodal integration theme extends to medical anomalies and benchmarks. Mayhay and colleagues present unsupervised detection of post-stroke brain abnormalities. Purohit and colleagues introduce Mars Bench for planetary vision tasks, fueling cross-domain progress. Tai and colleagues create datasets for pathology eye tracking, enhancing biological applications. Zhao and colleagues advance image compression with self-generated priors, reducing distortion for efficient storage. Overall, these themes interconnect, shifting vision toward integrated, adaptive AI systems. Key findings from the papers include several critical insights. Li and colleagues find that vision transformers naturally bind objects with 90% accuracy, aiding robotic scene parsing. Aquaviva and colleagues reveal that video pre-training enhances data efficiency for tasks like route planning. Zhao and colleagues achieve 15.7% less distortion and compression, benefiting telemedicine with crisp images. Zhou and colleagues expose segmentation vulnerabilities to universal attacks, urging stronger defenses for safety. Song and colleagues enable collision-free video stitching for loops, revolutionizing virtual reality and gaming simulations. Methodologies in these papers synthesize common approaches. Diffusion models refine noise into images or videos iteratively, offering strong quality but being compute-heavy, as seen in Deng and colleagues' work. Transformer architectures use attention for global dependencies, providing scalability yet being resource-intensive, as in Zhang and colleagues' example. Knowledge distillation transfers teacher model smarts to students for efficiency. Exemplified by Dulecha and colleagues, contrastive learning aligns features for robustness, improving generalization, as in Zhu and colleagues' approach. Hybrid methods blend stochastic and deterministic techniques for uncertainty handling, such as in Nguyen and colleagues' work. The first selected research paper is Generative View Stitching by Chonghyuk Song and colleagues from 2025. It is chosen for its novelty in creating collision-free videos along arbitrary paths, impacting virtual reality and robotics. The method uses parallel sampling and omni-guidance for global consistency, outperforming baselines in stability. It represents generative innovation, enabling seamless loops like Escher staircases without artifacts. Its high impact transforms animation and simulation by bridging vision with path planning. The second selected research paper is Rethinking Visual Intelligence, Insights from Video Pretraining by Pablo Acquaviva and colleagues from 2025. It is chosen for its breakthrough in pre-training efficiency, showing video models adapt faster than language ones. The approach employs adapters and benchmarks to embed spatiotemporal biases, reducing data needs significantly. It is representative of multimodal shifts with implications for robotics and education. Its novelty challenges language dominance, paving the way for visual-first AI intelligence. The third selected research paper is Conflict Adaptation in Vision Language Models by Hugh and colleagues from 2025. It is selected for its representativeness of cognitive-inspired directions, mimicking human conflict resolution. The work tests models on Stroop-like tasks with autoencoders, revealing adaptation mechanisms. It impacts resilient AI in chaotic environments, bridging psychology and vision. Its high novelty uncovers emergent traits, enhancing decision-making in vision language systems. Future directions in computer vision research point to developing fully multimodal systems that integrate vision with audio and haptics for holistic perception. Hybrid models incorporating physics are anticipated for realistic generation and simulation. Challenges to address include compute efficiency, dataset biases, and ethical issues like deepfakes. Benchmarks are expected to evolve for agent autonomy and self-evolving models like Viper. There is potential for video pre-training to create seeing AI agents, accelerating cross-domain synergies. This presentation was synthesized using AI tools GPT-Grok with model Grok 40709 for content generation. TTS synthesis was handled via OpenAI for audio narration. Image generation was performed using Google for visual elements. The content underwent review by a human expert to ensure accuracy and coherence. While reviewed, potential oversights may exist. All references are provided for verification. Subscribe to the YouTube channel for more deep dives into AI research. The channel title is AI Frontiers. Its description, unpacking the wildest edges of artificial intelligence through fresh arXiv preprint server papers. Hit subscribe and turn on notifications to stay updated on episodes like this. Share your thoughts in the comments. Let's keep the conversation going. In this podcast, we bring you the latest breakthroughs in computer science and AI. Straight from arXiv preprint server, from neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer, this video uses arXiv preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprintserver.org.